6.2 Matrix multiplication and inverses. Matrix multiplication. Dimensions are critical. Columns of first matrix must equal row of second matrix. Now when you multiply two matrices together, the inside dimensions here need to be exactly the same. If they match, you can multiply these two together. If they don't, you can't. Then the result will be the outside dimensions. The result is M by K matrix. Don't multiply corresponding elements like we did with addition or subtraction. So with addition and subtraction, you just add the corresponding elements, but with multiplication, you can't do that. With multiplication, it's row times column, row times column, row times column. And it's always addition in between. So the very first element in the solution, well, first of all, we can multiply a 3 by 2 times a 2 by 3 together because the inside dimensions match. We have a number in the first row for the first number in the first column, and then we have a number in the first row to match up with the second number in the first column. So we can take 4 times 7 plus 5 times 2. So 4 times 7 plus 5 times 2. We go row, column. Then the next one is row, column. We have 4 times 0 is 0, and then plus 5 times 6 is 30. And then finally we go row with the third column. 4 times 1 is 4, and then plus 5 times 8 is 40, so plus 40. And then we keep going with the second row. So we have second row, first column, second row, second column, second row, third column. We have 7 plus 18, 7 plus 18. Then we have 0 plus 54. Then we have 1 plus 72. And then we go with the third row. Third row with first column, second column, third column. We have negative 42. And then minus 18. With third row, second column, we have 0 minus 18. And then we have negative 6 times 1, that's negative 6. And negative 3 times 8, that's minus 24. Minus 24. Our final answer, well here it all is written out, but then our final answer is, we have, let's see, 28 plus 10. We have 38. We have 30, 44, 25, 54, 73, and then negative 60, negative 18, and negative 30. Use matrices A and B to find B times A if possible. We have a 2 by 3, and then that'll be multiplied times a 3 by 2. So it's possible to multiply the 2 because the inside dimensions match, and then the result will be a 2 by 2. So 1, 2, 1, 2, a 2 by 2. So we're going to go across on the first row and down on the first column. We have 28. 7 times 4 is 28. 0 times 1 is 0. And 1 times negative 6 is negative 6. And then we go across and down. We have 35. 0 times 9 is 0. And 1 times negative 3 is negative 3. Then the third one, it should have 3 numbers because there's not a 0 here. 2 times 4 is 8. 6 times 1, we have plus 6. And then 8 times negative 6, we have minus 48. And then with last row, last column, we have 10 plus 54, and then minus 24. Here's our final answer. We have 14, 32. 8 plus 6 is 14. We have 48 minus 14. That's going to be negative 34. And then on the last one, I think that's a 54, we have 64 minus 24. 64 minus 24, that's going to be 40. The number of touchdowns, field goals, points after touchdown, and two-point conversions for the 3 teams in the high school league for this season is shown in the table below. The other table shows the number of points each type of score is worth. Use the information to determine the team that scored the most points. Here are the two tables, and we're going to act like they're matrices. And this first table is a 4 by 1. This table is a 3-row by 4 columns. Now if we multiply the first table times the second one, it's not going to work. The inside dimensions are not the same. But if we take the 3 by 4 and multiply that times the 4 by 1, then the inside dimensions are the same, and the result will be a 3 by 1. Let's set up a 3 by 1. So let's look at the first row. We have 27 times 6. That's 162. Then we have plus 21, and then plus 4. The second row times the column is going to be 144 plus 36 plus 18 and then plus 6. And then the last row times the column will be 126 plus 42 plus 12 and then plus 18. That's equal to 208. The second row is equal to 204, and then the last row is 198. The team that scored the most points is the Tigers. Multiply. We have a 2 by 2, and we're going to multiply that times a 3 by 3. Well, the inside numbers don't match. Now, when we go row times column, we have -1 for -1. We have 4 for 0, but we don't have another one for 3, so we cannot multiply those two together. With this one, we have 1 row by 3 columns, and this one we have 3 rows by 2 columns. These two match, and we will be able to multiply these two together. The result will be a 1 by 2. 1 row, 2 columns. -2 and 2 is -4. We have -5, then plus 3. And then we have -2 plus 25 plus 6. -9 plus -3 is -6. We have 23 plus 6 is 29. Properties of matrix multiplication. For any matrices A, B, and C for which the matrix product is defined in any scalar k, the following properties are true. We have the associative property of matrix multiplication. You can regroup. Associative property of scalar multiplication. You can regroup with multiplying by a scalar. We have a left distributive property. C times A plus B you can distribute, and a right distributive property. You can distribute on the right also. The identity matrix. The identity matrix of order n denotes I sub n is an n by n matrix consisting of all ones on its main diagonal, from upper left to lower right, and zeros for all other elements. So we have an identity matrix, could be 1, 1, zeros here. We have ones on the main diagonal and zeros everywhere else. The identity matrix for a 3 by 3 would be 1, 0, 0, 0, 1, 0, and 0, 0, 1. On the main diagonal, we have all ones, and everybody else is a 0. Write the system of equations as a matrix equation, AX equals B, then use row echelon on the augmented matrix to solve for X. We have the system of equations, and we can solve this by turning it into a matrix equation. We have a 3 by 3 matrix, which is the coefficients of all of the variables, times x1, x2, and x3. And think about how we'd multiply this. We would take row 1 times column 1, which would be 2x1 right there, plus 2x2 plus 3x3, and that is equal to 3. Well, we could multiply the rest, and we would end up getting right back to all these equations. Now, the augmented matrix, we can remove the variables. We have an augmented matrix, and we can solve this system using row echelon form. So on this one, let's take row 1 and then minus 2 times row 2, and we can replace row 2. That means we have 2, 6, 4, and 10. We have 2, 2, 3, and 3. 2 minus 2 is 0. 2 minus 6 is negative 4. 3 minus 4 is negative 1. And 3 minus 10 is negative 7. We can also, let's see, we can take row 3 times row 1 minus 2 times row 3 and replace row 3. Now we need 3 times row 1, that's 6, 6, 9, and 9. And 2 times row 3 is 6, 2, 2, and 8. 6 minus 6 is 0. 6 minus 2 is 4. 9 minus 2 is 7. And 9 minus 8 is 1. Now I need a 0 here. We can take row 2 plus row 3 and replace row 3. We have 2, 2, 3, and 3. 0, negative 4, negative 1, negative 7. Then we have 0, 0, 6, negative 6. 6z is equal to negative 6. Z is equal to negative 1. Then we have negative 4y. We have minus negative 1, so plus 1 equals negative 7. Negative 4y equals negative 8. Y equals 2. Then at the top we have 2x, let's see, plus 4, because 2 times 2 gives you 4. And then minus 3 equals 3. 2x plus 1 equals 3. 2x equals 2. X equals 1. We have 1, 2, negative 1. Write the system of equations as a matrix equation, ax equals b, then use a calculator to solve the system. All right, we have 2, negative 1, 1, 1, 1, negative 1, 1, negative 2, 1, times x1, x2, x3. That's equal to negative 1, negative 2, negative 2. There's the matrix equation, and now we'll use our calculator to solve. Let's go into matrix. We want to edit. This is a 3 by 4, and we will enter in the augmented matrix. 2, negative 1, 1, negative 1, 1, 1, negative 1, negative 2, and 1, negative 2, 1, negative 2. We can get out of this, go back into matrix, go to math, and we want reduced row echelon form. And then go back into matrix again, and we want matrix A. We have negative 1, 2, 3. Key concept, inverse of a square matrix. Let A be an n by n matrix if there exists a matrix B such that A times B equals B times A, which gives you the identity matrix. Then B is called the inverse of A and is written as A to the negative 1, or in other words, A inverse. So A times A inverse equals A inverse times A, which is going to give you the identity matrix. Determine whether A and B are inverses of each other. If A and B are inverse matrices, then A times B is the same as B times A, which is the identity matrix. So let's look at A times B. That's equal to 25 minus 24. That's 1. Negative 30 plus 30 is 0. 20 minus 20 is 0. And negative 24 plus 25 is 1. So we get the identity matrix with A times B. Now, do we get the identity matrix with B times A? We have 25 plus, let's see, 25, right there, 25 minus 24. That's 1, looking pretty promising. 30 minus 30, that's 0. Negative 20 plus 20, that's 0. And negative 24 plus 25 is 1. Now we can say A and B are inverses. Which matrix below is the inverse of A? Let's have A. A is negative 4, 3, negative 5, 4. And we're going to multiply that times 4, negative 3, 5, negative 4. We have negative 16 and 15. So negative 16 plus 15, that's negative 1. That already disqualifies that one. So we have negative 4 and 3, negative 5 and 4. And we have negative 4, 3, negative 5, 4. We have 16 minus 15, that's 1. That's promising. Negative 12 and 12, that's 0. 20 and negative 20, that's 0. And then we have negative 15 and 16, that's 1. This looks like it might be a winner. But now we have to be able to go the other way and get the identity matrix also. We have negative 4, 3, negative 5, 4. We have 16 minus 15, that's 1. We have negative 12 and 12, that's 0. 20 and negative 20. And then we have negative 15 and 16 is 1. So we have a winner. Letter B is the inverse.